Now I did want to give you just a couple more examples of multiplication matrices. A few more examples. Just so you have them under your belt. So say I've got 2, 3, 6 times -1, 2, 6. Or not times, but 2, 3, 6, -1, 2, 6. And multiply that times 5, 3, -2, 1. Can I multiply these together? Anytime we start, we always want to check and make sure we can multiply them together. So I've got a 2 by 3, 2 by 3, you can tell where I grew up. And I got a 2 by 2, 2 by 2. Can I multiply these together? Nope. No answer. So that was quick. You always like these on a test, right? Well, let's try doing it backwards. Can I multiply them the other direction? So I have a 5, 3, 2, -2, 1, and 2, 3, 6, -1, 2, 6. Can I multiply these together? So I have a 2 by 2, and I have a 2 by 3. What do you know? Look, I can multiply these together. Okay, so first of all, before you go through the trouble of putting it in your calculator, make sure you can actually multiply them. But just because, so this is kind of neat. A times B may not work, but B times A might. Okay, so A times B might be non-existent, or you might have an answer for B times A, and this is why matrices are super crazy. Alright, so let's put this in as A, and we'll put this in as B. Now that I just got backwards, I guess we'll put it in as B and A, just to be consistent with what I've been talking about in the lecture. Okay, so I want to put in, what's going on with my funny little calculator? It looks weird. Put in my matrix. I'm going to have to edit them. Now, again, this does take forever, so you might just decide you don't want to mess with it. I'm in A right now. A is a 2 by 3, so I've already got the right size. And it's a 2, 3, 6. Oh, look at me. 2, 3, come on, 6. And then -1, 2, and 6. Alright, now I'm going to fix the other matrix, which is now a 2 by 2, and it's 5, 3, -2, 1. Okay, now I can go to home, clear those out because they're old, and now I'm going to put in B times A. So matrix B times matrix A, and there I got an answer. And I'm good to go. Alright, so sometimes you can get these things where, now if I actually try to put in A times B, let's see what it'll do. So let me actually try this. I'll try B, no wait, A times B, A times, let me try putting it backwards, times B, come on. It's going to say, look, there's a dim mismatch. Okay? Come here. So, this is the result of A times B. A times B gives me a dimension mismatch. Okay? So your calculator will tell you that you can't do it, but you'll have just wasted the last, 3 minutes plugging it into your calculator to find out that there's not an actual answer. I'm going to give you one more example. We'll solve it 2 different ways. Say I have A is 316 and B is 252, 2. Say I want to find A times B, and then later I'm going to find B times A. So first of all, I'm just showing these to you because they're column and row vectors. They're like, just one column or one row. So sometimes that trips up students, so I just kind of wanted to get you some exposure to this. So this first one is a 3 by 1. B is a 1 by 3. So we can multiply these together, and our answer is going to be a 3 by 3. Got it? Okay, now let's see if we can do B times A while we're sitting here. And this is also just so cool. I just think it's neat how it works out. B times A is a 1 by 3. A is a 3 by 1. So we can multiply them together, and we get a 1 by 1. So we're actually going to get a matrix with just one element this way. If we do it this way, we're going to get a matrix with 9 elements, which is, I just think, kind of cool, because it's like, how could you flip? I mean, all you're doing is A times B versus B times A, and you're getting these just drastically different answers, which I think is actually kind of ridiculously cool, which is probably why I went into all this to begin with. Okay, so let me put in my matrices. I'm going to go into my little edit box, and it's a 3 by 1, which is 3, 1, 6. And I'm going to put in my next one, which is B, which is a 1 by 3. See, it's even the right shape, so I know if I put it in backwards, it'll show me. It's just so neat. Back when I was a kiddo, we didn't have these. Well, we did, but my teacher wouldn't let us use them. So, here we are. Now I want to go A times B. And one of the reasons that I'm finding the sizes in advance is that now if I put it in my calculator and I get something that's the wrong size, I can say, well, maybe I put it in my calculator wrong or something. All right, so there's my answer for A times B. And let's find my answer for B times A. And there we go. So you can see here that, in fact, a little bit bigger, I did get a 3 by 3 matrix here, like this. There's my 3 by 3 matrix here. And then here's my 1 by 1 matrix here. So this is AB equal to that. And then BA is just equal to this little 1 by 1, which I think is just fantastic.